exercise 4, and this is proof of Formula 5, which is the derivative of a cross product of vector functions. So we're asked here, prove Formula 5 of the differentiation rules for vector functions. And basically we have right here, so d over dt, the derivative of the cross product of u of t cross v of t of vector functions equals 2. Again, it's always the same component of the product rule, or the same counterpart of it. So now we're going to have u prime of t, vector function, cross with v of t plus u of t, a vector function, cross with v prime of t. So basically this product rule. very, very similar to product rule. And then now let's take a look at the solution again, and now look at solution 2. And then basically using the definition of derivative of vector functions, as opposed to just doing the brute force derivative by components. So we're going to prove this using the definition of derivative. Let's take a look at it right here. So here's solution 2. So alternatively, we can prove Formula 5 via the definition of derivatives of vector functions. And before we do that, I just want to note, or basically also note the properties of the cross product from an earlier video, namely property 3 and 4, and also just note, be careful with the order of the cross product here. Basically, here's property 3 from an earlier video, and the link is over here. Basically, if you have A cross and then B plus C, well, then you could just multiply the cross products inside A cross B plus A cross C. But note that the order of them, you can't just go multiply A inside here, and you can't just have a B cross A like that. It's not going to be the exact same thing. So this needs to be always in line like that. If it's like this, just don't rearrange how it looks. Just put it inside the cross product for each one. Just add them up. And similarly for A plus B cross C, it's just equal to A cross C and then plus B cross C. So, but you can't just switch them. Yeah, you can't necessarily switch them there. And that's actually because of property 1 right here. Notice that if you switch them, you're going to have a negative actually. So yes, so yes, we have to be careful with that. All right, so let's go further. So let's do the definition. But first of all, I'm going to go let r of t, let's the vector function here, equal to, this just equals to, equal to the cross product just by themselves. So u of t cross v of t. And then we're going to do the definition of derivative there. All right, so if we have this, then let's go. Then what we'll do is, well, we know that r of t plus h, minus r of t. Again, and then we're going to divide by h after and take a limit and so on. But initially, this is just the denominator. I mean, the numerator. So this is going to be like this. So now we just do that, expand out. All right, so this equals to, we'll just plug it inside the u and the v there. So this equals to u of t plus h cross v vector of this is t plus h, and then minus, now we're going to have to minus the same exact setup there, but with the t. Cross, u of t cross v of t. Like that. So there's a cross product like that. All right, now that we have this, and here what I did was just quickly pause video and shrunk it to fit in here. So so now what the calculus book does actually is it takes the same right-hand side, but then what it does now is it's going to plus, I'm going to plus right here, and then it's going to do some quite unique setup here. So it's going to go plus, and then put this in a bracket like this. No, actually, we don't need a bracket. So we're going to just do it like this. So now it's going to go a plus u of t plus h, like this. And then it's going to cross with a v of t. So instead of t plus h, just has a t there. And then it's going to subtract it as well, so that we don't change anything. So this is still going to be equal to 0. So plus u of t plus h cross v of t, like that. All right, so then this right here just equals to 0. So we're not changing anything there. I'm just going to put a bracket, or I'll just leave it like that. So we just put it like that, or put a bracket, and, or actually, here I just quickly shrunk it and just pause it. Anyways, I'll just leave it like that. So we don't need to put a bracket, but we just added this separately, and just so that now we could do some tinkering. And now is where we can apply property 3 and 4. So here's 3 and 4. So if we have this, but now we're going to go with the reverse actually. So if we have A cross B plus A cross C, So we could factor out the a here. So we can factor out the a and then put it outside of the bracket. And then we can just add these c and b, add them up. So that is what we're going to do right now. So now what we're going to do is we're going to take the like term, this one, in this case, this one, and this one, and then this one. So this one and this one, we're going to take those and factor them out, and then we're going to have these as additions there. But actually, instead of these particular ones, the calculus actually does this one here. So this one and this one, this one and this one, because it has a minus sign. So this has a minus sign. So we want to, because we want to eventually cancel some stuff out. So so that's what we have. We're going to take those out. So this is going to equal to u of t plus h. And now this equals to a cross. So we can take this out. This could be our a. This could be our a. And now this is our c. And this is our b. Like that. All right. So that's what we all have. Now let's just erase all this. And pretty much got it straightforward. So now it's going to be, and now we'll just a bracket, v of t, and again, this is when you have to be careful of the order, so we don't change anything. So it's going to be now plus now, v of t, and this is because it's a minus, so we have to minus now because we factored out. Now it's a minus, so minus. And again, that's why we did the minus side. So we have a minus there, and we'll show this as we keep going. All right. All right, here I just quickly shifted it over to this side. And now the next setup is, well, we have these two left over. So we're going to factor out the like term, and that's v of t. Yeah, we're going to factor that out. So that's going to be our new, we'll call this c. This is our c. And then this is going to be our, this is the positive one. We'll move it on to the negative side. Well, this will be our b, and this will be our a. And then that's the property right here. So we'll have a plus b cross c, because this is what we have, a cross c. Instead of a plus, we have a minus. So we have a minus b plus c. So we're going to separate the c, which is this v of t, and then we're going to get this a minus this b. So instead of plus, we have a minus. All right, let's just all erase all this now. It's pretty straightforward if you just follow along the logic there. Okay, erase this, and erase this, erase the c, and erase the a. Okay, so it's going to be plus, and then we have to keep in mind the order, so we can't just put the v in front. So it's going to be now, this is our a, which is u of t plus h, and then minus this u, which is our b. And then bracket, and then this is going to be now, and then now it's going to be cross product with v, which we factored out using cross product rules. And here, yeah, again, I quickly just moved it over, just shrunk it, fit it inside this one line. So now dividing through by h and taking the limit as h approaches 0, we have, and now we're just going to apply the limit, definition of the limit or derivative of a vector function. So r prime of t is the vector function, the derivative or the tangent vector. This equals to the limit as h approaches 0 of this difference right there. Yeah, this whole thing, again, because that's just r of t plus h minus r of t. So now we're going to plug this whole thing inside, and it's pretty big. So what I'm going to do is, I'm going to just, actually we'll do this separately. So yeah, we could just take the limit and then also separate it. So I'll just write it all out, just be probably quicker. R of t plus h, then cross v of t plus h minus v of t, like this. Put a thing like this. Then divide this all out by h, and then this is going to be, this is, that's one of them there. All right, here, just fix that up, and now let's go to the next setup. I just shift it over here, now plus, and then put the limit inside on this one here. So limit as h approaches 0 of u, put the bracket like this, u of t plus h minus u of t, and then divide this by, actually a cross product with the other one, cross v of t over h. like that. All right, so that is what we get. All right, so now that we have this, well, we could just see what happens here if we just put the h inside here, the first term. We could just get that out of there. We could just take the limit on each separately. So this just equals to, we'll just plug in this inside. We're going to get a u of t. Yeah, so u of t. So when h goes to 0, we just get a u of t. And now this is going to be a cross with, we could put the limit inside there now, and that's going to be cross with limit as h approaches 0 of v of t plus h. Yeah, because we could just divide the h only on this one here that matters there. Because that looks like the limit. I mean, that looks like the actual definition of derivative for vector function, which it is. And then this is going to be plus. And now same thing with this side here. We're going to get a limit as h approaches 0 of u of t plus h. Okay, this is plus h minus u of t, then all divided by h. And then, and then I'll just put it here. Now we cross with, and then we just take this limit inside this one. This one doesn't even have a h there. Yeah, so we could just get that out of there and just leave it like that. This is v of t, like that. All right, and here I just shifted this over here so fit it all in one line. And now this one here, this is just the definition of derivative for a vector function. This is just v prime. Yeah, so we have, that's just v prime of t, the vector function. So again, this is just the limit as h approaches 0 of the v of t plus h minus v of t, and then divided by h. And this one is, then this one is the same thing for the u. Yeah, so this is just the definition of the vector function for u now. I'll put it like this. This is u of t prime. So u prime of t, like that, and that's just again a difference u of t plus h minus u of t divided by h. Again, just very similar to the, or just the exact counterpart of the normal functions in their derivative. So then this equals to, well, look what we have. We get u of t cross v of t. Yeah, v prime of t. Yeah, like this, and then plus, now this is u prime of t. And it doesn't matter which order in terms of the addition. And then cross v of t. So there it is. This is exactly the same setup as this, as going back up here. Yeah, going back up here. This is solution 1. We got this one here. It's the same thing. We just have this one in front there. We can just move it over to the other side. It doesn't matter. This is u prime of t. Cross v of t, and this one's u of t cross v prime of t. Again, exact same thing here, and you could shift these around. Addition, you could just, doesn't matter which way it is. Yeah, so there it is, and this is quite fascinating stuff there. Again, just using definition of derivative of vector functions. All right, and here note that I used properties a and d of vector function limits from my earlier video in this derivation. So basically, when I split these apart right here and take the limit, I just used this one here versus part A. This is properties of vector function limits. This one right here. So when you have a limit of that, you can just split them up like that. And then I also use part D. That's this right here. So when you have a cross product like this, it's the same thing as taking the limit of each one separately. So, and that's pretty much what I did over here. So I took a limit here, this cross product, and I just took a limit inside here and just put the h inside. This one here, this one has no h. I just separate that, and just take a, and then I can set up the definition of vector function limits for these two, and so on. Yeah, so that's quite epic stuff.